Forget the suffocating rush hour commutes on packed trains or the soul-crushing gridlock of city intersections. Something much bigger is happening. The global transportation order is being systematically rewritten. While most of the world is still playing catch-up with EVs and traditional infrastructure, a new technological frontier has emerged in China. We aren't just talking about cars anymore. These are machines that can take to the skies or even plunge underwater, evolving into systems that conquer any environment they face. In this episode, we explore 6 breakthrough technologies that are forcing global engineers to reconsider everything they thought they knew about modern transit. Stick around until the end to see how flying cars have officially transitioned from science fiction to the streets of China. First is the GAC GOVE Airjet. With this vehicle, every morning you no longer worry about being late due to dozens of cars lined up on the highway or the suffocating crowds on the subway, because this car can detach the cabin from the chassis, take off vertically in just a few seconds, and fly you straight to your destination without being bound by any route on the ground. Sound like too big a leap? In reality, this is how GAC Group solves the traffic puzzle in the current urban traffic environment. With a detached modular architecture, a core technical decision. This vehicle can be split into 2 separate parts. The upper flight cabin is made from monolithic carbon fiber, significantly reducing weight while maintaining extreme structural rigidity, a decisive factor in aviation, where every extra kilogram reduces flight efficiency. The lift system consists of 12 propellers on 6 axes, creating distributed and stable lift. If one motor fails, the remaining motors can immediately compensate for the power, minimizing the risk of loss of control. Takeoff load of up to 550 kilograms. While flying car models in the US and Europe still maintain an all-in-one design, forced to carry the entire wheel and suspension system during every takeoff, meaning they consume energy to lift things that do not serve the purpose of flying. The GOVE Airjet has completely eliminated the chassis, but it doesn't mean it's left behind. It is integrated to become an autonomous robot, meaning it is equipped with optimized positioning, sensor, and navigation systems, allowing it to move itself to the charging station, self-optimize its position, and be ready to pick you up when the cabin lands. You don't need to find a parking spot. The vehicle completes its own operational life cycle. So if a vehicle can self-detach, self-fly, and self-operate on the ground, can it still be called a car? Let us know your thoughts in the comments. At the same time, XPeng Aerojet is developing a different approach with the land aircraft carrier, a 6-wheeled vehicle carrying a foldable eVTOL inside. Not completely detached like GAC, but allowing flexible deployment without fixed infrastructure. One side optimizes radically. One side optimizes practical deployment capability. And when placed next to Tesla, which still focuses on ground electric vehicles and self-driving AI, we see a clear difference. One side is expanding into 3-dimensional space. One side is still maximizing ground exploitation. In summary, the GOVE Airjet is not just a vehicle. It is a new mobility infrastructure model separating functions, optimizing each environment, and connecting them into a self-operating ecosystem. And if this model is deployed on a large scale, in your opinion, will cities of the future still need roads as they do now? But if you thought flight was the final frontier of modern transport technology, this next machine will force you to redefine your entire understanding of safety and adaptability. A 3.5-ton SUV that doesn't just survive falling into water, but can actually float, self-stabilize, and continue moving like a true rescue vehicle. What happens if you're driving in the middle of a deep flood? The water rises, traditional engines stall, electrical systems shut down. That is the familiar and obvious scenario. But with the BYD Yangwang U8, that entire script is flipped. Instead of shutting down, the system begins to switch states. The vehicle body is automatically sealed to IP68, standards or rating usually reserved for high-end electronics, ensuring water cannot penetrate the battery or the central control system. The result? The car does not sink. It floats, like a completely sealed unit, equivalent to a small steel boat. But floating is only the first step. So what about movement? This is where the E4 platform demonstrates its full engineering value. The Yangwang U8 is equipped with 4 independent electric motors. Each wheel is a separate drivetrain capable of real-time torque control with near absolute precision. On the road, this system allows the vehicle to perform a 360-degree tank turn on the spot and remain stable even if one wheel loses grip. But when it hits the water, the role of the wheels changes completely. They are no longer for traction. They become propulsion. The electric motors spin the wheels, creating a water jet pushed backward functioning similarly to a propeller. A speed of about 3 kilometers per hour. Not fast, but enough to move the vehicle out of the danger zone. This system can be maintained for about 30 minutes. This is not just a demonstration feature. This is an entirely new layer of safety. In terms of performance, the Yangwang U8 produces 1,184 horsepower, accelerating from 0 to 100 kilometers per hour in 3.6 seconds. A 3.5-ton SUV equivalent to 2 adult rhinos can reach speeds like a supercar. However, the core point is not the speed, it is the controllability. The 4 independent motor system allows torque distribution to each wheel in real-time, maintaining stability in all conditions, from dry, slippery roads to frictionless environments like water. Compared to traditional amphibious vehicles, which must sacrifice design, add propellers, and trade off land performance, the Yangwang U8 doesn't have to choose. It retains the full experience of a premium SUV. But when needed, it switches states from a transport vehicle to a survival system. No mechanical structural changes, no bulky additional parts, only through software and electric drivetrain architecture. In summary, the Yangwang U8 is not just a car that can go underwater. It is a vehicle that can adapt to the environment, no matter how that environment changes. So in your opinion, when vehicles start adapting themselves instead of depending on infrastructure, how will the future of transportation be redefined? And if water is no longer a barrier, then what happens when vehicles don't just fly, but fly themselves, without human control? The next machine I want to introduce is the XPeng Voyager X2. This is a 2-seater eVTOL model developed by XPeng Aero HT, a specialized flying car subsidiary of XPeng. This is no mere prototype. This is a definitive stride forward for the global flying car industry. In 2022, the X2 completed its public flight in Dubai, under the direct supervision of the local Civil Aviation Authority. That was a critical milestone because it proved the system could function outside of controlled test environments. In terms of structure, the X2 utilizes a monolithic carbon fiber fuselage, lightweight, rigid, and aerodynamically optimized for flight, with a length of approximately 5 meters and a width of nearly 4.8 meters. When folded, the entire vehicle shrinks to under 2 meters, roughly the size of a standard motorcycle. This is exactly what a true personal flight vehicle looks like. Regarding performance, the Voyager X2 reaches a top speed of about 130 kilometers per hour, with a continuous flight time of 35 minutes at altitudes under 1,000 meters. Figures that may not seem overwhelming compared to traditional aircraft, but are perfectly suited for urban mobility scenarios. With city distances of 10 to 20 kilometers, this level of performance is enough to slash travel times from dozens of minutes to just a few. In your opinion, when travel times are cut so drastically, how will human lifestyle habits change? However, the greatest breakthrough of the Voyager X2 lies not in its speed or range. It lies in how it is operated. This vehicle is designed with a nearly fully autonomous system, allowing users to simply input their destination, while the entire process of takeoff, navigation, obstacle avoidance, and landing is handled by the central control system. This solves one of the biggest hurdles for personal flying cars, not the flight technology, but mass usability. The difference becomes even clearer when compared to global rivals like Joby Aviation, whose eVTOL models exceed 300 kilometers per hour with larger payloads, targeting the commercial air taxi model while still requiring pilots in the initial stages. Additionally, many flying car lines currently being tested worldwide also choose the safer route of air taxis over personal vehicles, such as Archer Aviation, with vehicles carrying more passengers and focusing on service operations. Meanwhile, the XPeng Voyager X2 takes a different path, smaller, lighter, shorter range, but strictly targeted at the individual user. If you are truly passionate about flying cars, you definitely cannot overlook the Kuickwheel Sky Rider X6. This is no longer a car, nor is it exactly a drone. It is a flying motorcycle in every sense, a machine designed to take the personal experience into the air in the most direct and primal way. The Sky Rider X6 was developed by Kuickwheel and made its first live flight demonstration at CES 2025, one of the world's largest technology stages. With global pre-orders now open, it's clear this is no longer just a test concept but a vehicle nearing full commercialization. The first shock comes from the design. It has no enclosed cabin, no traditional vehicle frame, and almost no detail that resembles a familiar motorcycle. Instead, the entire structure is stripped down to a monolithic carbon fiber frame where the rider sits directly on the fuselage, much like a speeder bike straight out of a science fiction movie. At its core, the Sky Rider X6 is an ultra-lightweight personal eVTOL system. It utilizes 6 large electric propeller axes arranged symmetrically around the body to create lift and maintain stability during flight. Unlike a helicopter with its main rotor, unlike traditional drones with their box frame designs, the X6 is fully optimized for the personal experience, compact, agile, and highly responsive. The entire body is crafted from lightweight composite materials, reducing overall mass while ensuring rigidity during high-speed operation. This is critical because in a vehicle without a protective cabin, every aerodynamic factor and stability element must be handled with surgical precision. Regarding its core technology, the Sky Rider X6 is equipped with a multi-layer redundant flight computer system integrated with LiDAR sensors and automatic stabilization. This allows the vehicle to continuously scan its surroundings, adjusting the thrust of each propeller in real time to maintain balance, even in the face of turbulence. In other words, the rider doesn't need to fly the craft. They only need to steer it. The X6 control system is simplified to the extreme. One joystick, a few basic maneuvers, and the rest is handled by the electronic brain. The control experience feels more like playing a video game than operating a traditional aircraft. In terms of performance, the Sky Rider X6 is speed limited to approximately 72 kilometers per hour in urban environments. Not incredibly fast compared to a plane, but enough to create a sensation completely different from ground travel. More importantly, this speed is optimized for safety and control rather than just chasing raw specs. When placed alongside enclosed eVTOLs like the XPeng Aero HT or Western Air taxis, the Sky Rider X6 follows a completely different philosophy. It doesn't focus on full automation. It doesn't target public transport. It focuses on the personal experience, direct, flexible, and rich with the thrill of control. While American companies like Joby Aviation or Archer Aviation are developing miniature electric planes for air taxi services, the Sky Rider X6 feels like a different move entirely. It brings the concept of flight back to its most personal level, just as the motorcycle once did for ground transportation. In summary, the Kuickwheel Sky Rider X6 may not be the most powerful or the safest vehicle in the eVTOL ecosystem, but it is undeniably one of the boldest. If you thought the previous machines were impressive, this next one will force you to rethink the entire definition of an SUV, the Mengshi M Hero 917. This isn't merely a means of transportation. It's a mechanical platform built on military logic, subsequently civilianized for the streets. Developed by Dongfeng Motor and officially commercialized in 2023, the M Hero 917 marks a milestone proving China isn't just stopping at mass-market EVs, but is expanding into ultra-high performance vehicles integrated with tactical technology. The core of this vehicle lies in its platform. It inherits DNA from armored military vehicles machines designed to operate in extreme terrains where grip, traction, and survivability matter more than pure speed. This means the M Hero 917 isn't optimized for comfort. It's optimized to conquer environments where conventional vehicles fail. The M-Hero 917 boasts up to 1,088 horsepower and a peak torque of 1,400 Newton meters, figures typically reserved for heavy-duty trucks or military hardware. In reality, this level of torque allows the vehicle to generate massive traction from a standstill, enabling not just rapid acceleration, but sustained grip while climbing steep slopes or surmounting heavy obstacles. But the real story isn't how powerful it is. It's how it wields that power. The M-Hero 917 has a 100% climbing capability, equivalent to a 45-degree incline, a level most commercial SUVs can't reach due to limits in center of gravity, traction, and load distribution. To achieve this, the drivetrain must continuously adjust traction at each wheel, ensuring no single wheel loses grip during the ascent. This pushes it closer to military operational logic than to a civilian car. Another groundbreaking feature is the crab walk, which allows the entire body to move diagonally like a crab, with a steering angle of up to 10.6 degrees. This might sound simple, but mechanically it requires an ultra-precise four-wheel steering system, synchronizing the movement of all wheels in the same direction. The result? The vehicle can escape tight spots, rocky crevices, or mud bogs without having to turn around, a massive advantage in complex off-road environments. It looks like a military-spec version of a Jeep or a Ford Ranger. But what truly sets the M-Hero 917 apart is its accompanying ecosystem. This vehicle features an optional integrated roof-mounted scout drone capable of automated takeoff, following the vehicle and transmitting real-time aerial imagery. This transforms the vehicle into more than just a means of travel. It's an observation platform, a mobile reconnaissance hub that can see what lies beyond the driver's line of sight. However, unlike the American GMC Hummer EV, one of the most powerful off-road electric vehicles currently available, with its rugged design, high power output, and impressive off-road capabilities. While the Hummer EV focuses primarily on raw power and pure off-road capability, with features like crab walk still within the realm of a more powerful than average vehicle, the M-Hero 917 is the high-end version of a versatile mobile fortress. The vehicle is no longer just a transportation tool, it's evolving into a technology platform, or perhaps to serve something even further beyond. Finally, we have the technology where you can practically become one with the machine, much like the way super soldiers transform. That is, the InMotion V13 Challenger. At first glance, it is just a minimalist electric wheel, possessing almost no grandiose design elements. But that very simplicity hides a landmark advancement, where the entire power of a high-speed vehicle is compressed into a structure so small it is almost absurd. The V13 Challenger is not merely a mobility device, but a statement that size limits in the personal vehicle industry no longer exist. With an architecture featuring a 126-volt high-voltage system combined with a 10,000-watt peak power motor, it allows a top speed of up to 97 kilometers per hour, a figure approaching road motorcycles, yet controlled entirely by the human body. No steering wheel, no throttle. The entire operating experience relies on acceleration sensors and center of gravity shifts, turning the rider into more than just an operator, but a part of the system where every micro-movement is translated into traction, direction, and speed in real time. And it is at this point that it becomes completely distinct, not because it is larger, stronger, or more complex, but because it does the opposite, shrinking the full power of a motorcycle into a single wheel, while erasing the boundary between man and machine, turning movement into a direct, almost instinctive experience where technology is no longer something you control, but something you merge with. Combined with a 22-inch off-road wheel, a 90mm air suspension travel, and a range of up to 200 kilometers, the V13 Challenger is not just a high-speed device, but a vehicle capable of practical operation in various environments, from urban settings to complex terrains. Looking back at all the machines we've just explored, one thing is crystal clear: the laws of physics are being bent. Vehicles are no longer shackled to the ground, the water, or traditional structures. They are evolving into intelligent systems that can fly, float, and conquer any terrain with unprecedented flexibility. More importantly, these are no longer just laboratory dreams. These technologies have hit the real world, proving that the global race is no longer about who invents first, but who can deploy faster and at scale. Which machine on this list impressed you the most? And as we look toward the future, do you think we are ready for a total revolution in how humanity moves? Drop your thoughts in the comments below, and don't forget to hit like and subscribe to Massive Tech so you never miss our next deep dives into the future of engineering. See you in the next video.